Hello,
Hello.
Jesse. Hi. How are you doing?
Good. How about yourself?
I'm doing good. I'm fit and optimistic as usual.
Cool. That's a good state to be in. How was last week for you guys?
Pretty good. Two major developments stand out. I finished up a pull request that makes the Triton VM prover use a whole lot less memory at the expense of a modest performance downgrade. So where previously you needed gigabytes upon gigabytes of RAM, now you can do it with just a handful of gigabytes of RAM, but it will take you maybe twice as long to produce the same proof. That was a 3 weeks long endeavor or something, and I'm glad to say it's now finally wrapped up in a pull request. And by the way, I documented the logic that we use in every step. So if you are a Stark enthusiast and wonder how we did a couple of things, then have a look at the pull request or at the source code for that matter. Um,
And
yeah,
is
go
is
ahead.
is each proof equally computationally intensive?
No, it depends on what you're proving the correctness of. If you're proving the correctness of a very short and simple program, the proof production is short and simple. And if you're proving the correctness of a long and complicated program, then it's long and complicated. And there are plenty of programs that cannot be proven, or at least not in one go, because they're just too complicated.
And so this waiting upon the proof, this would not be that you're waiting on the block to be confirmed or your transaction to be included. It's before you're even interacting with the blockchain. Is that correct?
That depends on who does the proving, and if you're just making a transaction to send money privately using Neptune, then you can get away with doing a very producing a very simple proof, simple and straightforward proof. And it will be the miner's task to integrate that short and simple proof into a proof of correctness of the entire block, which is a much more complicated task also.
But for proving that, that's part of what they get the reward for.
Yes. Yes, they have to prove the correctness of the block before they get to sample and uh, guess the nonce. And that part is the same as it is in Bitcoin. For every nonce, you get one hash trial, and only if the hash of the block is smaller than a target difficulty do you get to claim the block reward.
But does that mean that each block is gonna may vary in terms of how much time it takes to approve?
In principle, yes, but that's not a big issue because the time it takes to verify it is independent
Is independent of what?
of the time it took to prove.
Okay, because it's instant or what?
It's basically instant, and since every block contains a proof of correctness of the previous block, we're always stuck to the recursion threshold. And so the verification time will never be less because there's always the proof of correctness of the previous block, and the verification time will never be more either because whenever you're proving the correctness of a more complicated program, what you're going to end up doing is you're going to split it up into chunks and prove each such chunk individually.
Okay, so looping back to what you started with, that you made this optimization, so it takes a bit longer, but you're using less memory. Uh, was that a big win, or is that sort of a difficult trade-off, or how are you?
It's not a satisfying trade-off. I had expected this result beforehand, but along the way there were a couple of intermediate milestones where we got less memory and faster provers, and that was a hooray on all fronts. But in order to get the most drastic memory reduction, you have to do some work twice. There's just no way around that.
And can you give us a feeling for the scales involved? So let's say a simple transaction. How long does that take to prove on a consumer laptop?
The last time we tried, it took about around 20 seconds on my laptop, the laptop on which I'm calling you right now. And that was supposed to be the simple program to be proven, and even that program is not complete yet. Uh, that said, since the last time we tried, there have been a ton of improvements to Triton VM, and we expect a ton of improvements on the program itself also. And so I think we're looking at 1 to 2 seconds to produce a transaction on a consumer grade laptop like the one I'm calling you from now.
And what were you testing in this case? What was it, a simple transaction, or what was the test?
It was unlocking UTXOs and producing a removal record, which is what you need to make the mutator set work. That's the it's basically the mixnet that generates privacy, or that obfuscates the origin of UTXOs while still accounting for them through some obfuscated origin database.
And what is unlocking the UTXO?
Well, I don't want you to be able to spend my coins. So my coins are tied to cryptographic data that only I possess, which is my secret key. And yet, on the blockchain, there is a commitment to my coins because that's how I know that I own them and everybody agrees that I own them. And so there has to be a way to link this commitment to my secret key. And that link is the lock script, which is a very short computer program that essentially takes a uh, random string of information and hashes it, um, and verifies that the hash matches a hard coded digest that's present in the program itself.
I'm not sure I understand why you need that. Maybe start over. Explain the same thing again, and
Well, if it's not there, then nothing prevents you from spending my coins.
but to spend your coins, I would need your private key. No.
Well, that's exactly. I mean, you're not going to get my private key and sit on it. You're going to, if you have my private key, you're going to use it somehow. And what I'm describing is what you would do if you had it.
But because the unlocking is confusing me, because spending one of your UTXOs with your private key, I would use the word spending. Is that different from what you mean by unlocking?
No, it's basically the same. I'd say spending
Okay.
is a very high level description based on a metaphor of what happens in the real world. If you look into the mechanics of what actually goes on under the hood of spending, then you'll see that it involves the unlocking of UTXOs.
Okay. Gotcha. Okay. Cool. So that was the first topic that you worked on this week, right?
Yeah, and then another topic that we didn't work on per se, but we did raise in the course of discussion, and in fact, I think we're open to feedback on this topic from the rest of the world, is transaction and more specifically address formats. So right now, Neptune has only one type of address format, which is generation addresses, or that's how we call them at least. And they are supposed to emulate a paper wallet. You write the secret seed phrase on a piece of paper stored in your vault and don't open that vault for the next 20 years. But meanwhile, you can send money to a public receiving address that you generated from that seed phrase or simultaneously with that seed phrase. And so every year you send $50 or something like that. Um, that totally works. Um, but the trade-off is that this generation address, what it is it's basically a public key, because in order for privacy preserving transactions to work, both sender and receiver need to contribute randomness to the pre-image of what is going to end up being the commitment to a UTXO, that is the input on the input side of the transaction. And
Yeah,
so how
both need to contribute like a random string,
a
random
random string
number.
of bits.
Okay.
Um, and well, the receiver, uh, the receiver's randomness is embedded inside this receiving address, but the sender's randomness hasn't been decided yet at the time when you generate this address. I mean, that's up to the sender to generate. And so what the sender needs to do is he needs to communicate to the receiver securely what this randomness is. And that's what the public key is there for. You use the blockchain as a mechanism to transmit this information, the sender randomness. In addition to the coins which are being transferred, you need to transmit this sender randomness so that the receiver can spend the coins in a privacy preserving manner. And so
Yeah.
this induces a bit of a trade-off, because if you receive multiple payments going to the same receiving address, how does your client know that those payments are for you? Well, it knows because these ciphertexts, they announce their recipient.
Explain what ciphertexts are?
A ciphertext is the encryption of a message, and the message in this case is the sender randomness. And so, yes, you can use the blockchain to transmit these, because only the receiver can decrypt this randomness. But the receiver does need to know that there's a message for them in this transaction, in this block. And that's because the way the receiver knows this is because that transaction is marked as such. Hey, whoever owns this public key, here's a message for you. There's an announcement to that effect. And so if you send, if multiple different people send coins to the same receiving address, this is if this is a generation address, then those transactions will be able to be linked as going to the same recipient, which is not ideal. But it's a trade-off that we know exists, and we want to be open and transparent about. And by the way, it's also a conscious
But the
choice.
trade off between what and what?
Uh, we decided to prioritize in this case the long-lived and secureness of the backup. So you have your secret seed phrase in your vault. You can burn your house down. You can sell all your computers, or your computers go down with the fire. As long as you have your secret seed phrase, you should be able to recover all your funds. That's the
Hmm.
idea. Um, and in order to achieve this, we're actually using the blockchain as a medium of transmission. So whenever you have your secret seed phrase, you know what the receiving address is, you know what the hash of the receiving address is, and then you can start scanning blocks or asking peers, hey, do you guys know of any transactions going to an address that looks like this?
Okay, so you're saying to enable that feature that you're able to recover everything from a seed phrase, the trade-off towards enabling that is that it's somehow traceable.
Traceable is a big word, but
Mhm.
there is a sense of linkability here, and that's if you reuse the same address. And right now, we don't even have the option to generate a second address from the same seed phrase. And of course, if
Right.
you have the capacity to generate 1,000 addresses from the same seed phrase, that's technically not very difficult. The challenge is, how do you then know that ciphertexts are intended for you? Well, you can run a counter, but if your counter runs from 0 to 1,000 for every block, that means you have 1,000 times as much work to do.
I'm not sure. I'm understanding the part where you miss that message if you're using multiple addresses.
You know which receiving address you have generated, or actually, you don't know this. You know which receiving addresses you might generate.
Well, let's start. Can we start with two?
All right,
So
let's
I've
start
got
with
two.
two. So you have a secret seed phrase. It lies in your vault, and you want to recover the coins that it unlocks. How do you even know that you generated two? You write that on the note somewhere. So in addition to 18 words, there's a message scribbled underneath those 18 words saying, I used these words to generate two receiving addresses. That works totally fine.
Okay.
And then you scan every block or ask peers um, for transactions that send coins to one of those receiving addresses. Two is fine. The problem is, what if you don't know how many receiving addresses you generated?
And in what context would you not know that?
Well, if you like to use a new receiving address for every transaction, every time someone sends you some coins, you generate a new address.
And so if somebody sent that message to one of those addresses, then it would be hard to. It would be difficult, right? It wouldn't be
It would
impossible.
not
It
be
would be difficult
impossible. It
to.
would be difficult. And so this difficulty might cause some perception of flaws, or what is it, perception of mistakes or of bugs. That's really not the case. But we decided, if you're gonna do,
But again,
go ahead.
let's talk about the message again because I'm not sure I fully understood that. The message is like a flag saying what exactly?
The owner of this public key has a ciphertext to decrypt here, and usually that means that there's coins that can be unlocked with that ciphertext.
Okay, and this you worked on this week, or you implemented this, or you made a
We
trade-off?
discussed
Well,
it
what's the
this
contribution?
week. There's no progress, just synchronization, and I guess there's progress in the back of our minds, but not in terms of the code base.
And summarize it one more time for me because I'm sort of getting small pieces, but I don't have the full
Every
picture.
seed
So
phrase can
what?
generate only one receiving address, and transactions to the
Mhm.
same receiving address can be linked to each other. That's the current state of affairs, and we're not sure how much effort to put into supporting other address types. By the way, this also means that
And hang on. What would a other address type be?
one where the sender randomness is not encrypted using a public key ciphertext, but transmitted through some other channel. Um,
Okay, so I forgot about the part with the random text. So to be able to send a transaction to that address where which is linked to only one seed phrase, they both parties need to send the ciphertext. The receiver they can both parties need the random string. The receiver can include that in their public address, the sender cannot, so they need to send it as a message. So they include in their transaction a flag for the receiver. Hey, for this public key, there's a there's some text here, which is his random message to complete the transaction.
Exactly that. Yes.
Okay. And I remember we had a discussion a while ago where you also talked about different address types. I'm assuming that's the same discussion, the same topic.
Probably yes. This qualifies as address types, but I don't recall what we said in the course of that conversation, so we might as well rehash.
But is it, would that mean that, because you're saying address types, you're not saying the transactions would work differently, or that I guess what I'm wondering is why address type? Why not upgrade the way addresses work?
Um, if the sender does not contribute randomness, then the sender can. No, hang on. The sender needs to contribute randomness in order to guarantee some privacy property that I can't pinpoint off the top of my head. There's a reason why it's there. Maybe it has to do with the sender being unable to determine when the coins were spent, or the other way around. Because naively, you'd think the receiver's randomness makes that difficult. But yeah, some particular privacy feature requires that both sender and receiver contribute randomness, and then the question is, how does the sender's randomness get to the receiver? And if you use out of band communication, then this entire question becomes moot. If you can send that randomness through an email, or through an overlay protocol, or transmit it to them via a thumb drive, that's all fine. Then this ciphertext does not need to touch the blockchain. And by the way, transactions in that case are far smaller too. There's not.
I get that. That's probably a separate discussion. But you mentioned address types. So break down again. What would be the new address type?
It would be the hash of a lock script, and that's it. Lock script is the only thing that you need to unlock your UTXO, and as soon as a lock script is attached to a coin, those coins are yours.
I think what I'm not understanding is far more basic. I'm afraid it has to do with why. It sounds like you're saying, listen, we've the addresses that we built have this limitation. We're going to build new addresses in the future, and my question is, why not just upgrade those addresses? Just get rid of the old ones as soon as you have the new ones. Why are you conceptualizing it as like a second type of address?
Because this if you're using some address type where the ciphertext is not needed because it's transmitted through out of band communication, then you cannot any longer rely on the secret seed phrase as the master backup.
Why not?
Because you received some randomness from the sender through some out of band communication.
Yeah.
You store it on your hard disk so that the wallet on your computer knows that it received those coins, and then your computer catches fire. Your secret seed phrase back in your vault does not know this randomness.
Gotcha. Gotcha. So it's not the way I understand what you just said is not just it's like a different type of a different way of doing the whole transaction. It's not just the address that's that
Correct.
type.
Yes,
Is that
that's a
fair?
fair characterization, right? The address type says I want my transactions to have this format.
Okay. Interesting. Yeah, I'm noticing that there's quite a few sort of paradigm shifts in the
Yeah,
Neptune world.
one thing I wanted to say right now is that is that the change addresses are the same. Um, well, actually, right now they're not, but since we only have one address type, it means that if I send you coins and I from one UTXO that I have to split up so that you get the right amount and I get the change back, where do I send that change to? You can't just say yourself because yourself is not a receiving address. I have to send it to another UTXO that I own, and conceptually there are two options. One is I record all the data to unlock this new UTXO myself on my hard disk, and I make sure that my hard disk doesn't catch fire. And the other option is I record a backup on the blockchain using an encryption that only my secret seed phrase can decrypt. And right now, I think we're actually relying on the first. And so part of the discussion
Okay.
was shouldn't we include those change addresses as covered by the same secret seed phrase? And one argument was, well, no, the secret seed phrase use case that's for send only and spend once. Um, in which case, if you want to spend from a secret seed phrase and you want to keep hold of the change, then that change needs to go to the receiving address tied to another secret seed phrase.
Why is there change again?
Because I own one Neptune, but your services that you deliver to me only cost 0.77. And so I want to pay you 0.77 Neptune, and the remaining 0.23 go back to me.
But you cannot just pay 0.77.
No, every time you spend coins, the old UTXO is removed from the UTXO set.
Right, right. Okay. That's also like a shift from because we tend to think in terms of balances. We non-crypto people, and then but it's different. You need to think in terms of the unspent transaction. Okay. Okay. Cool.
Yeah, so I guess that turns into a
Anything else?
question. What's the use case that you would be using Neptune for, and would you use Neptune with this basic support for generation addresses only, or would you wait until we add support for something more refined?
I mean, for me, the kind of the beauty of Neptune is that I would not tell you what I'm gonna use it for. I have the ability to be completely private, and that's yeah, that's pretty pretty amazing. Um, what was the second part?
Well, whether our plan to implement other generation, other wallet, excuse me, other address types, whether you would wait until those are in place or start using it already before.
I mean, I'd start using it, but you're also my brother, so that's I'm biased. And there's one use case that does come to mind, and that's donating to
Right.
to WikiLeaks. I would
Yeah,
use
and so
Neptune for
in
that.
this particular
Just
case, the authorities would be able to tell, okay, this address has received donations from. They wouldn't even know where from that, but they would be able to count the number of donations that this address received, but they wouldn't be able to link it to the senders, and they wouldn't even be able to know how many persons generated those 2,000 donations. It could be 2,000 donations from one secret key.
okay, so it gets split up in a sort of random number
No,
of transactions as well.
but you could do that if you wanted to. You just send a whole bunch of smaller transactions, and the nice thing about Neptune transactions is that the amount is secret to everyone except the sender and receiver.
Yeah. Yeah, interesting. It opens up a whole new playing field, and I'm really curious to see what
So
happens there.
that's a good note to
Cool,
close this conversation, I'd say.
for sure. Yeah. Good luck
Nice.
next week,
Yeah.
and speak
Ciao.
to
Bye
you in a
bye.
week. All right. Ciao, ciao.